Welcome to the Talking Reliability podcast, where the future of maintenance meets the power of sound. Hosted by Chris Hallam from uesystems, we're diving deep into the world of predictive maintenance, asset reliability, and cutting-edge ultrasound technology. Whether you're on the plant floor or leading reliability strategies, pull up a chair, or better yet, grab your hard hat, because we're bringing you real talk, real stories, and real insights from the experts who keep industries running. Let's crank up the volume on reliability. Well, hi everyone, and welcome to another episode of Talking Reliability with me, Chris Hallam from uesystems. Today is a great episode and one that I've been looking forward to for a long time now, ever since we agreed to have this recording. And joining us today is Jade Thompson from SKF Recond Oil. Hi Jade, how you doing?
Hi Chris, I'm really good, thank you. How are you?
I'm not too bad, thank you. I'm not too bad. I really appreciate you coming on board today. And you know, if anybody doesn't know who Jade is, I mean, Jade's been very, very famous, I would say, around the world of the UK and Ireland in the world of oil analysis. And if you don't know Jade, then you should. And hopefully through this podcast, you're going to get to know who Jade is. And first of all, Jade, I'd like you to, if you wouldn't mind, give it a bit of an introduction to yourself, your background and what SKF Recond Oil do.
Absolutely, and thank you for having me on, Chris. It's a pleasure. So I started off in the oil blending industry. I did 5 years working in the labs, helping with the blends. So basically from refined base oil through to a finished product that people that we're speaking to hopefully today use on site. And then I moved into more of the aftermarket side. So I started working and running labs, delivering consultancy and training for lubrication-based projects on the used oil side. So we'll say once it's been through the asset and during it working its functions in mechanical assets. I did around 8-9 years for a CBM-based company, managing the lab, delivering the consultancy. And then I started at SKF 2 years ago this month, working on a really exciting project, which is Recond Oil. And I'm the UK champion for Recond Oil. So anything oil-based and lubrication in the UK tends to come to me.
Okay, excellent. It's very, very thorough there, isn't it, as well? Your experience then is not questionable at all. With those sort of things. I mean, when it comes to Recond Oil, I mean, what do you guys, what is that? What is that sort of area you're dealing with there?
So Recond Oil is an innovative offline filtration system, we'll say. So it's a very effective offline filtration system. But what we've done at SKF is develop something called DST, which is double separation technology. So we've took standard mechanical filtration, which we use in all inline and offline filtration systems, and we've merged that with a chemical filtrant. So they are now together in one filter insert, and this allows us to filter oil way below 1 micron. So usually if you filter oil below 1 micron, you're going to start degrading the lubricant, breaking up hydrocarbon chains, which is what the oil lubricant's built of. So we're going to start having negative effects on the lubricant. So we have then brought in this chemical filtrant to complement that. So the chemical is designed to pull the smaller particles into bigger particles, so then the mechanical insert can then hold on to it. So it's quite innovative. It's a very exciting project, and it's the reason that I joined SKF. It's quite well on its way now in industry. We've got lots and lots of applications around the world where this is working, and it's allowing customers to move to a more circular use of lubricants. So we're aiming for circular use of oil for our clients. And we do that by using our own SKF DST lubricants that we blend ourselves. And this allows us to top up the additives as and when the time comes. So we're keeping super clean oil, improving reliability of the asset and reliability of the lubricant. And then as and when we need to, topping up additives. So we can essentially use that base oil for an infinite amount of time.
Oh, that's fantastic. That's brilliant. So, I mean, this episode today, Jade, we're looking at oil as a predictive technology, or
Yeah.
oil analysis specifically. And, we see lots of people embarking on predictive maintenance programs using things like vibration analysis, thermal imaging, ultrasound, and oil and that. And sometimes I think oil analysis is sometimes overlooked or not necessarily given the attention that I think it maybe deserves. With your experience in that, are you able to, maybe for the people that are new to this even, or even never done anything on the predictive technology side, could you go into a little detail about the use of oil analysis as a predictive technology as well, please?
Yeah, absolutely. And I must agree that is something really common. So when we do our in-person event, mine is named I do condition monitoring, and oil analysis, because it isn't seen as a predictive technology or a condition monitoring technology. Um, so with regards to that, I split oil condition monitoring or oil analysis into three categories. And we've got suitability and design projects, general OCM, so general oil condition monitoring, and then root cause analysis. So it really can be used in all three time phases of the asset's life cycle. So if we're looking specifically at the general oil condition monitoring, it's used predominantly to assess the health of both the asset and the oil. So we're wanting to see how much life have we got left in the lubricant? Is the lubricant doing its correct job? And how is the asset doing? Are we seeing any wear? Are we seeing any contaminants that might contribute to wear further down the line? So we're looking at specific failure modes for that asset, specific failure modes for that lubricant, and keeping an eye on them and making sure that everything is running as it should. The minute it's not, we change something to make sure it is.
Okay, interesting. And when it comes to that sort of approach, is it something that a site has to take the samples themselves and send it to a lab, or is it something they can do on site? Is there different ways in which you can do that too?
Yeah, absolutely. So there's inline methods, which would be oil sensors, such as a particle counter or a wear debris sensor, or there is samples that are sent to the lab. So depending on the application, I know you and James Sylvester touched a lot on this in one of your last podcasts, criticality and FAMICA are vital for deciding which oil analysis technology to use, which test suites to run within the lab, and when to do each one. So, for example, a particle counter in line will give you lots of information, such as basic cleanliness codes, relative humidity, and temperature. This helps with critical assets to keep an eye on it constantly and make sure we're looking at the key factors that will affect the asset. Taking an oil sample, which sites can do, or there are plenty of companies around the UK that will come and take the samples for them and get them off to the lab. That gives them the extra bit of information that they need to be able to predict failure modes or see failure modes starting to occur. The particle counter or inline sensors will do that for you, but the lab analysis gives you much more information at every failure mode that you might possibly come across with regards to lubrication. So it's important that customers or end users use both and make sure that they're used in the correct way. So things like FAMICA studies are vital for that, to understand, can I use a sensor? When and should I also use oil analysis from the lab, or should I just stick to oil analysis or just to a sensor?
Oh, excellent. That's brilliant. I mean, yeah. Forgive me for my ignorance on some of these things, but we can know a little bit about everything, but not specialize in certain things, and hence why I really appreciated you coming on today with this to explain some of these things because. Yeah, everyone else is going to get some good education out of this, but so am I, and I'm quite happy with that too. So that's brilliant.
Good.
I mean, when it comes to taking these samples, then Jade, I'd imagine there must be some form of risk to human error or risk of contamination maybe in that. And is there something you see quite often, or what sort of misconceptions do you find when you're going out talking about this with people in industry?
No, absolutely. Taking a sample is the biggest risk to using oil analysis as a predictive technology. There's a really common phrase to maximize data density and minimize data disturbance. and the sampling process is the biggest risk to data disturbance. We need to make sure that the sample we're seeing is representative of the system, all the usual things that you hear. But if the sample is then, as you say, labelled incorrectly, not transported correctly, it's left on a windowsill for a week, and then the oil starts to degrade further than it actually is. So it's super important that when people are deciding we're going to use oil analysis as a predictive technology and incorporate it into our maintenance strategy, then it's done correctly and a correct lubrication route is set up. So the samples are taken properly, recorded properly, got to the lab as and when they should. And the same with inline sensors. They need to be programmed correctly. The data needs to go to the correct people, so to not cause panic, and make sure that the data that is received is being used as information to drive maintenance forward, to we'll say have a proactive approach and constantly improve. You and James also spoke about reliability and the definition behind it and feeding back to OEMs. And that's so important. And I've done lots of projects with OEMs before where we've had an end user and an OEM involved, and we have used the data that we've got to drive reliability changes from the OEM down the line. But back to your question, misconceptions. The main misconception is we'll take oil samples every month. As and when it gets too contaminated or we see too much wear, we'll change the oil, take another sample. Everything's now green, everything's now okay. When nothing has changed apart from the oil has been changed. And then people all of a sudden think, oh, my reliability is back on track and the asset's now more reliable, where them wear modes still exist, them contamination ingress points still exist. All we've done is lost the data and the trends. So it's super important that people understand changing oil does not stop failure modes, doesn't stop contamination getting in. Changing the oil just loses the data, loses the information trend that you did have to understand how severe an issue is this, how chronic or acute is this issue, what can we actually do about it, is what people should be saying. So in some cases, we do need to change the oil if it's heavily degraded, but we need that information up until that point to be able to decide what should we actually do next.
That's really interesting, actually. I think that actually ties into a case study that I had once before with a user that was using ultrasound, and they had had a planetary gearbox sent out for a refurb, and they got in touch with us after it had come back into service because they found that they had some strange sounds coming from the gearbox when they were listening to it with ultrasound. And it sounded coarse. It should have been smooth and uniform in nature, but it sounded coarse. But it had just been refurbished. So again, knowing a little bit about certain different technology, because our recommendation to them was to, well, take a check of the oil, take a sample of the oil as your first check. And they did that. And bearing in mind this was just back from refurb, they said that the oil was actually black, and it turned out that they used the wrong type of oil as well. And so they had it taken back out of service, cleaned up and everything else, and then put back with the right oil. And the sound, the friction level from the sound was perfect, was great. But again, I think there is one where I guess you put it down to human error, but even having, the right type of oil for the right asset as well is important as well, would you say?
Yes, absolutely. I've seen gearboxes running on engine oil, and we've had some wonderful cases over the years. And when I deliver training, I do a lot of training, as you know. My main teaching to people is I try to get across a lubrication route, a lubrication survey, a lubrication maintenance schedule doesn't need to be difficult. It's very simple. If you get to a gearbox with a green oil can and it's got a red label on it, it's very simple to say, I'm in the wrong place here at the wrong time, and I've definitely got the wrong oil can. And we have seen lots of cases like that, but the solution doesn't need to be complex. It doesn't need to be a big digital AI-driven program. It can literally be a simple color-coded system that will prevent lots of issues. And we had a simple case quite a lot of years ago now. where we kept getting oil analysis back, and the amount of wear that we were seeing from this gearbox was really high, and they kept changing the gearbox. And I said, please let me come to site, because this is not normal. This is not running in wear. It's not what we would expect to see in the infant phase. So I got to site, and these gearboxes are installed on an angle. So the guy's showing me, saying, this is where the oil level is. We've done the oil level to that. And, well, these are designed to be horizontal, and we've not got it mounted horizontal. So we got a boroscope, and the gears were not lubricated whatsoever. The oil was all sat down in the bottom corner. So the oil analysis was telling me something was wrong, but sometimes it's just a good old let's have a look. Obviously, with the boroscope, we don't want to open it up and cause too much downtime for no reason, but then it gave us the information of we need to reassess the oil levels. And again, a lubrication route doesn't necessarily need to be over the top, but we just need to see, is that oil level going to cover the bottom half of that bottom gear? If not, we're not going to be getting any lubrication to the bearings or the gear. So yeah, sometimes it doesn't need to be complex, but it can cause catastrophic issues if there's nothing in place.
No, that's fantastic. It's nice to be able to show case studies with these things, and it's kind of, with any sort of technology approach, by showing people how these things work, it's the only way that people can sometimes see it and learn it. And as you were saying there, previously about people doing these checks and getting the results back, and then seeing, oh, something's changed in the condition of the oil, so they don't really think about what's caused it to change, but they just think, well, it's the oil there. The oil is changing. If I replace it, then everything's fine.
Yeah.
They don't actually then go further to go, well, why was that the case and such. So, I mean, you also you touched on it there as well about training and your delivery of training. I mean, if somebody was looking at getting into this, say I'm Joe Bloggs, new reliability engineer on a site, and I'm now looking at oil analysis for something in our site now. What sort of training is available, or what would you suggest the right sort of training path or program for somebody to get into this, from not knowing much at all to I don't know, being an SME as such? What's the sort of path would you recommend?
I would always recommend starting with an awareness course. There are courses such as the BINDT LA Cat 1 and 2 and the ICML courses, MLA, MLTs, and they're all fantastic courses that reliability engineers absolutely should attend. But I think that we should always start with an awareness course. And the reason for that is because it's a big subject. It's quite a scientific subject once you get into it, which is mixed with engineering. So it's really important that people have an awareness, can go away, practice that, develop that. And also, usually awareness courses can be bespoke. A lot of the awareness courses I deliver, I will want to go to site, see the processes, the assets, then I'll want to see their oil analysis data, and I will turn up to the course ready to teach them what they need to know based on their site, how they're currently working, what do the stores look like. And then after maybe 6 to 12 months of practicing what they've learned on the awareness course, then going and doing the BINDT or the ICML courses, where they not only get a formal qualification, but they go into much more depth. They understand the science behind it. And what, in my opinion, that does is trains them in a different way of thinking. It gives them an analytical mindset, and it teaches them, right, oil analysis is not a set of numbers. It's a set of information that's telling you several different things all at the same time about one asset. That information is pretty useless if we don't understand the process, the asset, the components in there, the maintenance that's happening. And that's another common misconception with oil analysis, is that we send the sample off, don't give the lab any information, and we're going to get information back. The information that comes back is usually quite poor. People get frustrated with the oil labs, and having a really good line of communication between your analyst or your lab manager and site is crucial to an oil analysis program working. And it's very same with all technologies, as you'll know with ultrasound as well. If people half-heart it and have the lowest service or lowest costing option possible, and then that information is not linking with what's actually happening on site, what's in the process. We've got a sample with a ton of water in. there's no steam nearby, there's no water sources nearby, we need to look to stores. But if we don't understand that, it's really hard to get proactive actions from the data.
Yeah, no, absolutely. I think, yeah, that's fantastic. That's great. I mean, yeah, you're right. And it's like when I'm talking to customers or people that are looking at, investing in ultrasound technology, I get frustrations where people think, well, I've heard of a buzzword, I've heard of a technology that's going to cure my problems, but when you end up going to see them and you look a bit deeper, then they're not even getting the basics right first before they even implement the technology. And if they didn't get the basics right and just implemented the technology, they'd cause even more problems. And I can imagine, you must get some frustrations when you visit people to see, something around their oil stores or something like that, where they're looking at doing something, but you look further down the line and say, look, what's going on here? I mean, do you see those sort of things as well?
Yeah, hopefully no one's listening, but about 3 weeks ago when I was on site and we were doing an assessment for Recond oil for them to be able to recondition their lubricant, use it more environmentally friendly, but also get more reliable lubricant health and more reliable asset health, we'll say, because this was a process where material comes into the oil and it gets churned around the assets and it is part of the process. So we were trying to keep that under control. And as I decided, right, let me come to site on a day where you're changing the oil so I can see every part of the process, every part of the line and fully understand. And as soon as we walked onto the line, the guy said, so this is the first gearbox. This is 100 and whatever litre gearbox with 320 centre stroke gearing. And there was a really small fill port with the filter in as it should be. And the guy took the whole side of the gearbox inspection cover off in there with his little transfer pump, getting rid of the oil. And I said, so why have we opened the inspection cover when we've got the drain and the fill port there? This is quicker. So I said, right, I understand that, but what we're doing is adding airborne contamination into the gear, and that's what's going to affect your bearings. And, it's really clean in this factory, the guy said. I said, so for us, it's really clean, but for your gearbox, it's the microscopic particles that are way below 40 micron, way below the end of one of your strands of hair. They're what are going to start affecting your bearings. We think about clearances or a micron and below on most bearings. We can't see them particles. And the guy, no, we clean this down this line. There's going to be no contamination. So we went down the whole line. We did the reconditioning assessment. And then after that site visit, we had a small get together after, and I said, I want to offer you guys some free awareness training, because what I've seen today, it's really important that you guys understand that, because you can spend thousands of pounds on any technology you want, do as much analysis and monitoring as you want, but it is not going to make a difference if the bare basics aren't in place. Using the correct tools, using the correct methods, we may as well put used oil back into that gearbox, because we've just recontaminated the whole process. And it's the same with simple filter changes. You go to site, watch them carry out a filter change, the new inserts rolling around in the dirt before they actually change it in. And it happens all the time, which is why awareness courses are really important, that they're bespoke to that site. They're not just a textbook course where the clients can't actually relate. They need to relate to their specific assets, their specific process for them to go, oh, actually, that might be right. We'll try that going forward.
So, yeah. So, and the question is, did they take you up on that awareness training?
Yes.
Excellent. Yes. So there's a win. Yeah. That's great.
We've not done it yet, but it's planned in. So hopefully we'll get a win. Yeah.
Oh, that's fantastic to hear. I mean, yeah, I think sometimes, we talk a lot about these technologies. We talk a lot about reliability. And I think there should be some form of course that's just basic things or called like that, a Cat 1 in basicness, where learn how to have good husbandry, how to have good practices that are just basic simple things that will help you with those sort of things too. So I mean, that's great. So we've talked about the training side of it, and Jade, if there was one key takeaway from this podcast that you wanted people to listen in and take in and consider, what would you recommend to somebody right now that's listening to this, potentially, that's thinking, I need to look further at this? Where should they start, Jade, in your opinion?
In my opinion, with regards to their site, they should start with what's most critical to process, a simple FAMICA, but mainly start with a basic condition assessment of site. So oil analysis is quite daunting when people get the first reports, and we need to understand the failure modes, criticality to process, but a basic condition assessment of site is where we would take a sample of all the greases, all the oils in stores, all the greases and all the oils in use in assets on site. And that gives us a really blanket condition assessment to say, right, we've got a lot of greens there based on our FAMICA studies, criticality analysis. We know they're okay to process, they're not key. This is where we start. This is what we focus on first. Oil analysis doesn't need to be daunting. It also shouldn't be a tick box. We shouldn't be just sampling everything for the sake of it. It needs to be used as a predictive technology to help predict things happening. And my key takeaway is use oil analysis for much more than just general oil condition monitoring. It's such a powerful root cause analysis tool. A few years back, we used it to root cause some failures where members of the public had got injured. And had it not been for the oil and grease analysis that we did, they probably wouldn't have root caused that. And many more of these assets could have failed and caused more members of the public to become injured. So it is really critical as a root cause analysis tool, as well as general oil condition monitoring. Information wise, there is tons of information on the internet for people to start. I'm always more than happy to speak to people and help people out on where to start. But a general condition assessment for me, it seems over the top, but it gives people a really good complementary set of information to go with the FAMICA and the criticality, which you and James spoke about. It's so key when starting any condition-based maintenance or condition monitoring technologies on site, because you need to know where to start and where it's unnecessary and where it's irrelevant.
No, that's as key takeaways go. That's brilliant. There's a great pitch there, and I think, Jay, we could go on for hours, I think, talking about all these sort of things that we've seen, and we're going to keep it a bit short for now. But the good thing that we can tell everybody is that, you know, if they want to know more about this, then you're always there. You're always out. Look Jade up on LinkedIn, everyone. She's always proactive on there, showing things that they're doing and everything else. But later this year, on the 2nd of October at the Engine Rooms in Warrington, we are doing Talking Reliability Live. And Jade is going to be there as well, aren't you, Jade, with your Recond oil team? So, you know, you can come along to that and you can quiz the hell out of Jade. And I'm sure you'll be more than welcome to have people quiz you all day long, Jade, hey? And you'll be talking as well at the event too, won't you?
Yeah, absolutely. I'm going to discuss going from tick box based use of oil analysis to using it as an actual performance indicator, but on a really basic level. So just showing people how oil analysis can be used as a predictive technology rather than just something that they do.
Excellent. And I'll be making sure I bring my notepad and pen for that as well. So, no, Jade, I'd like to thank you for coming on board. It's been fantastic. And to be fair, I've learned quite a lot from this. And so, yeah, I'd like to thank you. And hopefully, everyone, make sure to follow Talking Reliability LinkedIn page. We're on Spotify. We're on YouTube as well. So, yeah, and sign up to the event as well at talkingreliability.com, where you'll see myself and Jade in October. So, yeah, with that all said, thank you, Jade. Thank you very much.
Very much, Chris. Thank you for having me.
No, excellent. And thank you for joining us, everyone. And we'll speak to you again soon. Thank you for listening.